We're going to start today's lesson looking at an absolute value graph and then transformations of that graph. So right here, we have the graph of y equals the absolute value of x. That means when you put x values in, so let's say x was 1, the absolute value of 1 is 1. It's 1 unit away from 0 on the number line. If you plugged in -1, the absolute value of -1, it's also 1 unit away from 0 on the number line. If you plugged in 2, that's 2 units away. If you plug in -2, it's also 2 units away. So you would plot that point and that point. If you kept going, you would basically get a v. Okay, so that's what's called the parent function. A parent function means that every single one of these absolute value graphs is going to be some derivation of that v. It could be right side up, it could be upside down, it could be skinny, it could be flat. But it's basically always going to have the same shape. Now, the shape is going to change depending on the values of this A, of this H, and of this K. All right. And these little boxes down here tell you how those values will change the graph. If we look here at these A values, if the A is negative, it's going to flip the V upside down. And the value of the A, like the numerical value, that's going to change the slope of the lines, okay? So that V is just made up of 2 lines with the same slope, just positive and negative, okay? This H value here, right, that's going to move the graph left or right. And it's going to move it the opposite direction in which you think. If it's x minus 3, it's going to move it right. If it's x plus 3, it's going to move it left. That's what this negative is indicating. It's the opposite of what you would think. Okay, and this K value here, that number is going to move the graph up and down, and that's just normal. So if it was like +5, it's going to move the graph up 5, the V up 5. If it was -5, it would move the graph down 5. So we're going to take a look at some examples now, and it's going to probably make a little bit more sense. So the first thing we're going to do here in example number 1 is we're going to figure out what is the value of A, of H, and of K. So there is no number here where the A would be. So if that's the case, that number is just 1. The H value is 3. Okay, is 3 because it's minus H. So that H value is 3. And my K value right here is 2. And that's going to be a positive 2. So please take note, the H value is always the opposite sign and the K value is the sign. So how does that help us? Well, the first thing that we're going to do is we're going to look at this H and this K. That's going to be the vertex of the graph, the bottom point. Okay, so we go to 3, 2. All right, that's going to be the bottom of the V. Okay, the slope is going to be that A value, but it's going to be positive and -1. And my graph is going to open up because the A value is positive. Okay, so what do I mean by positive, -1? I mean, as I move over 1, I'm going to go up 1. Move over 1, I go up 1. So this side of the graph has a positive slope of 1. The other side of the graph, as I move over 1 to the left, I go up 1. This actually has a negative slope, right? So that's my graph. The only thing that's happened is I've moved it to a new vertex of 3, 2, and it's still going up 1 over 1, up 1 over 1 to the right, up 1 over 1, up 1 over 1 to the left. Okay, so the slopes, we do say though that the slopes are both positive and -1. Now, domain and range. So domain for these is really pretty easy. This black line goes forever to the left and forever to the right and forever up. So my domain is going to be all real numbers. So we can write it like that, right? We go from -infinity to positive infinity. Or I'll show you how to write all real numbers in a second. Okay. Now the range, it's going up forever, but it does have a minimum value, right? A minimum value right here. So it never goes below this line here where y is 2. So my range is going to be y is, greater than or equal to 2. Okay. All right. Let's take a look at this next one. So let's fill in our values, right? We've got right there. Oh, that should be red. My A value is -1. Okay. My H, nothing is happening in there. So really that's just going to be like X minus 0. So my H is 0 and my K is 2. Okay. So my slope again is just that 1. It's going to be positive, negative. But because that A is negative, this graph is going to be upside down. It's reflected over the x-axis. My vertex is at 0, 2. Okay, so we'll go ahead and graph that. We go to 0, 2. And my slope is over 1, down 1, over 1, down 1. And it's upside down because that 1 was negative, right? This value tells me how I'm moving. The negative tells me if it's opening up or down. The domain, again, is all real numbers. And that's how you can write that without writing the infinity symbols. It means all real numbers along the x-axis, okay? And my range, y has to be less than or equal to 2. You can always tell your range by looking at the k value. It's either going to be greater than or less than, depending on if the graph is opening up or down. So this next one, I would like you to pause here, try on your own, and check against my answers. How'd you do? If you're stuck, call over one of your co-teachers. All right, we've got 3 more for you to practice. So why don't you pause this, try those, and come back and look at my answers. Okay, so problem number 2 there, the graph is opening up because A is a positive 1/2. The vertex is at 1, 3. Domain is all real numbers, and the range is y is greater than or equal to 3. All right, number 3, this graph is opening down because my A value is a -2. Vertex at -1, 4. Domain and range, you can see there. Here, the graph is opening down because my A value is a -3/4 with the vertex at 1, 2. The slopes are going to be down 3 over 4, down 3 over 4 the other way. And you have domain of all real numbers, and the range is y is less than or equal to 2.